How do you read a schematic? How do you find a compressor, a fan motor, or on a gas furnace, a pressure switch, an igniter? How do you read schematics? In today's video, I'm going to show you how. You're watching HVAC Tips for Technicians. I'm Tad. This is Taddy Digest. Let's go. First, we're going to learn how to read schematics for this air conditioner. What components does an air conditioner have? Outdoor fan motor. Looks like we got a compressor. And then there's some wiring going to something on the copper over there. Looks like some type of sensor or pressure switch. What other components do we have? We've got, in the electrical compartment, a dual capacitor and a contactor. Let's find the compressor on the schematic. We found the compressor in the unit. Now we found the compressor on the schematic. This is the compressor on the schematic. And notice it doesn't look like the actual compressor. It's just a symbol. Now, I'm not just looking for the compressor. I'm asking, how does power get here? You saw that the plug or the harness for the compressor had 3 wires, a red, a brown, and a black. The black goes to the C, which stands for common. The brown goes to the S, which stands for start. And the red goes to the R, which stands for run. And these are compressor windings. Now, if we want to know where the power comes from, we can go back to where the power comes into the unit. This is where you start on schematics. You start at L1 and L2. That's the 230 volt power supply. It comes from the contactor and it goes to the compressor. So if we follow L1, it's a black wire that goes to C. If we follow L2, it's a red wire that goes to R. And then, of course, we've got another wire that's red that goes to our C on our capacitor. And then from the capacitor, we've got a brown wire that goes to the S on the compressor. These diagrams may look complicated, but they're just simple paths. You don't want to try to read the whole diagram at once. You want to just read one path, one simple path at a time. If you can match what you see in the unit on the diagram, you can troubleshoot anything. All right, let's see if we can find the fan motor. We found the fan motor in the unit. Here's the fan motor on the schematic. You can see we got the same amount of wires, brown, red, black. We do have a ground wire though. And if we follow the black wire that goes to C, goes back to L1. Just like the compressor. That's where we're getting our power. That's one side. Go back up, follow the red wire that goes to R. Goes to the other side of the contactor, L2. And then we go back up, and the S, brown wire, fan terminal of the dual capacitor. Now we know our paths and where our power comes from. Now let's find our pressure switch on the schematic. Here's our high pressure switch. You can see the 2 wires. We had 2 yellow wires going to that pressure switch in the unit. HPS. If you don't know what that means, or what anything means on a diagram, go to the legend. The legend is for explaining what abbreviations mean. So it says HPS means high pressure switch. Now we went over the high voltage side of things. Now we're going over the low voltage side. This is our control circuit, our control voltage. You can see these wires come from our thermostat. And we've got one wire that's blue going to one side of what looks like CC. What does CC mean? It means contactor coil. The contactor has a coil. One side of the 24 volts goes to that CC. It's a blue wire. The other side, that circuit, that path, goes through a pressure switch before it gets to the other side of the coil. So if our safety, our high pressure switch opens, it will prevent this coil from being energized. And when the coil for the contactor energizes, it closes the circuit and it provides voltage to the motors. So the control voltage is like what tells it to run. And then the high voltage is what makes it run. Always look at your legend if you don't know what something means. Now let's look at the last couple of components, and we're going to find those on the schematic. So this component is called the contactor, right? We've got high voltage coming into this contactor, and it's labeled L1 and L2. That is our incoming power. Then we've got our outgoing power, which is labeled T1 and T2. So we should have 240 volts coming into this contactor. We've got a yellow and a blue wire on the sides on those spades, and this is our control voltage. This is our coil voltage, 24 volts. This contactor has high voltage that goes through, and then 24 volt low voltage that goes to the coil. Now over here, we've got our dual capacitor. This is what feeds the outdoor fan motor and the compressor for this equipment. We've got a HRM, a fan, and a common terminal. And the HRM feeds the S on the compressor. The fan terminal is usually a brown wire that comes from the outdoor fan motor's brown. And then we've got another wire which is labeled C. And that usually feeds, there's usually a wire that comes from the contactor to that terminal, and then another wire that goes to the compressor. Now over here, we've got our thermostat wire coming into the unit. Because this is single stage and it's conventional AC, not a heat pump, we've only got 2 wires. This is what tells the unit when to run, right? The high voltage is what makes it run. Let's take our multimeter, put it on volts AC, and I'm going to show you that this is our control voltage. We got the meter on volts AC. We're going to put our leads on the yellow and blue wire. What do you see? Nothing, because we're not calling for cooling. Why would we send 24 volts out to the unit when we don't have a call for cool? Only when we turn our thermostat on to the cooling mode will we have voltage that will energize that contactor coil. Let's go ahead and turn the unit on cooling. Now we're checking with a call for cooling, and you can see we've got 24 volts. That means that we've got 24 volts to our contactor coil if the pressure switch is closed and there's no issues. Now, if we take the meter, leave it on volts AC, and check right here at the contactor, L1 and L2, the incoming power, what do we got? We got, 240 volts. Now let's check the outgoing side. See the outgoing side? This is the load side, not the line side. Now what happens if I take this yellow wire that's feeding the other side of the coil and I take it off? And then I recheck load side. Well, the contactor's not closed, so we no longer have voltage. Now let's find the contactor and the capacitor on the schematic. Here's our dual capacitor. You can see, got the fan terminal. Brown wire from the fan goes to the S. We got the HRM terminal. Brown wire from the compressor goes to the S of the compressor, and then the C. And the C goes back to the line side of the contactor, red. And here's the contactor. How do we know it's the contactor? It says right here, contactor. And then we have the CC. Remember on the legend, it says contactor coil. And then you can see that we've got our L1 and L2 being fed by the power supply coming into the unit, single phase, 208, 230. And then we've got our coil, blue, yellow. We've also got some optional things over here. When it's got a 1, a number beside it, usually that's a note. And you'll come over here and you'll look at the notes. This is how you read a schematic for an air conditioner. Now let's look at a gas furnace and see if we can find all the components on the schematic. With the gas furnace, we've got a bunch of different components like gas valve, we've got pressure switches, inducer motor. Let's find our inducer motor first. All right, this diagram is a little different. On this side, we have a ladder diagram. This is for the sequence of operations. On this side, we have the wiring diagram, physical connections. The ladder diagram shows what turns on first. The wiring diagram shows where the wires go. Anytime I read a furnace diagram like this, I start with the call for heat, and that is W. From W through the safeties to the first component. Now let's find the inducer. On the ladder diagram, it's right here. It's IDM. If you look at the legend over here, it tells us the abbreviation. The abbreviation is right here, inducer motor. On the wiring diagram, you can see it's right here, IDM. We've got a white, a red, and a black wire. You can see there's 1, 2, 3. This is a plug. That plug goes from here to the plug on the board. The inducer motor is the first thing that turns on in a call for heat. It pulls a draft through the heat exchanger. Then we're going to close the pressure switch, allowing the system to continue. If the furnace won't start, check the inducer motor first. Now let's go through the sequence of operation from what starts first to what starts last using the ladder diagram. So we get a call from the thermostat, so between C and W we now have 24 volts. Our inducer motor, our draft motor, is energized and it comes on first. Then all our safeties should be closing. The pressure switches, the rollout switches, the limit switches, all those should be closed. When they close, pressure switch only closes when inducer motor starts. So when they're all closed, then that will allow power to be sent to the HSI, the hot surface igniter. If you've got a spark igniter, that's a different igniter. This one glows. It glows, and then the board sends power to the gas valve. Gas valve opens, and then we have flame. After a certain predetermined time, whether it's 30, 60 seconds, then our main blower motor kicks on. And that's the sequence of operations with the ladder diagram. Now we're going to use the wiring diagram, and we're going to go through that sequence of operations one more time. So here's our printed circuit board. Here's our inducer motor, the IDM. This is what comes on first when we have a call for heat. Where does our 24 volts come in from? The thermostat. And it goes right here on the board. You can see this little terminal strip with C and W. When we get to 24 volts, inducer motor comes on. Then you can see this plug, and there's a path from that plug that goes through all the safeties. So once our inducer motor comes on, then our pressure switches should close. In line with the pressure switch circuit is our limit switch, R2 rollout switch, ROS1 and ROS2. Once this circuit is complete, then we should have power to our hot surface igniter. Hot surface igniter is right here, HSI. We should have 120 volts. We got 2 white wires. That should start to glow. When it glows, then we should have power sent to our gas valve if all of our safeties stay closed. So gas valve gets power, it opens, sends gas through to the burners. We have a flame, and then to keep everything going, we have a flame sensor over here. And that flame sensor sends a signal back to the board, letting it know that it's got flame, and that's called flame rectification, and that's our sequence of operations. Now that we've looked at the wiring diagram, the ladder diagram, and the schematics, let's dive into the gas furnace and identify all the components. Let's start with what starts first, our inducer motor. After our inducer motor, our 2 pressure switches should close. Then we've got our additional safeties, and there's one back here, and that's our limit switch. We've got 2 safeties up here. This is rollout number 1 or rollout number 2. After all of our safeties are closed, then we should have power going to this white plug. That white plug feeds what's back there, which it's hard to see. You can't really see it. It's a hot surface igniter, but it will glow. After that, we've got our gas valve. Gas valve gets sent power and it opens. So the gas coming to that gas valve then goes through it, and then it goes into the burners. That provides the flame. Then on the opposite side of the hot surface igniter, we've got this purple wire going to something known as a flame sensor. That flame sensor will then send that signal back to the circuit board. This circuit board will see that there's flame, and the flame will stay lit because the gas valve will have power. Now, we've got a transformer down here, and then back behind this circuit board, we've got our blower motor, which you can't really see it, but that's the components that comprise this gas furnace. Start at the beginning, follow the path. If you know the sequence, you can find the problem every time. If this video helped you to learn more about schematics, definitely hit the like button if you like the video. Subscribe, smash that bell, ding, so you know what I'm doing. Hope you enjoyed today's video. Hope you learned something. If you did learn something, let me know what it was down in the comments. You got a question? Remember, questions can lead to new content. So put your questions down below. But if you don't have a question, that's okay. Let me know who you are and let me know where you're from. If you want more videos like this, go check out my playlist, HVAC Tips for Technicians. I've got hundreds of videos of live experience as a technician in the field to help you be a better technician. You've been watching HVAC Tips for Technicians. I'm Tad. This was Taddy Digest, and I'll keep you cool if you let me.